Hello everyone, welcome to the solution of test number 10 named as ITF, investigative function. Okay, so let me check all the things. Yes, everything is fine. I start with question number 1. In question number 1, we have in question number 1, we have a equation sine inverse x plus sine inverse y plus sine inverse z is equal to 3 pi by 2. As we know, maximum value of sine inverse is pi by 2. Okay, so each sine inverse can take maximum value pi by 2. It means here our LHS maximum limit is 3 pi by 2 and I want LHS to be equal to RHS. It means LHS has to attain its maximum value, which is only possible when each sine inverse takes value pi by 2 simultaneously. Okay? And when each sine inverse will take value pi by 2, when x, y, z, all three will take value 1. So if x and y and z, all three will take value 1. So what is our required thing? Sigma r equal to 1 to 2 x raised to 100r plus y raised to 103r divided by x201 y201. So if x is 1 and y is also 1, it means our this thing is a constant quantity, which is 2, and this is 1 actually. So 2 plus 2, it means since this is independent of r, so this is actually 4. Now let's move to question number 2. In question number 2, cos inverse cos 12 minus sine inverse sine 12. So these all things we can see through graph. Okay? So cos inverse cos 12, how we can find out? Okay, so how the cos inverse cos graph would go? Okay, so actually 12 would lie between 3 pi to 4 pi, and cos inverse cos graph, if you will see very carefully, this is something like this. Okay, so 12 would lie somewhere here. So what is this line equation? This line equation is y equal to number minus x, 4 pi minus x. So its value would be actually 4 pi minus 12. How the sine inverse of sine x graph look like? So this is 3 pi 4 pi. Sine inverse sine graph look like this. Okay, here and here. And actually if you see very carefully, 12 lies somewhere here. 12. Okay, 12 lies somewhere here. So what is this line equation? Y equal to x minus number. So we can write 12 minus 4 pi. Okay, actually there is a minus in between. Okay, so if we will find out this is 8 pi minus 24. Now let's move to question number 3. In question number 3, we have a function sine inverse x whole cube plus cos inverse x whole cube. We have to find out its maximum and minimum value. Okay, so for simplification purpose, let's suppose sine inverse x as t. So we can write this is t cube, and cos inverse x, of course we can write pi by 2 minus t whole cube. Let this as some g of t. Okay, now if we simplify this, let's apply the formula a cube plus b cube. So this is a plus b, which is pi by 2 into a square plus pi by 2 minus t whole square plus minus t into pi by 2 minus t. If you simplify this, you will reach t here. That you can do pi by 8 into 12 t square minus 6 pi t plus pi square. Now this is clearly a quadratic in t. Where is its vertex? Okay, its vertex would be at vertex at t equal to minus b by 2a, 2 into 12. So which is pi by 4 actually. Okay, now if we try to make it obviously, since t is sine inverse x, so obviously this will be from minus pi by 2 to pi by 2. T is restricted. Okay, sorry, close. Okay, pi by 2 close. This is also close. Okay, so now let's make it graph first. Okay, how g of t would look like? G of t versus t. So its graph will look like something, since its vertex is at, this is minus pi by 2, this is pi by 2, its vertex is at pi by 4 actually. So its graph will look like something like this. Okay, something like this. Now, clearly from graph we can see its minimum value would lie at pi by 4. So g of pi by 4. So if you will find out inputting the function of g here, okay, so this will be pi cube by 64 plus pi cube by 64. So this is going to be pi cube by 32. What is its maximum value? Its maximum value would be at, as you can see, its maximum value would occur here. So g of minus pi by 2. If you will find out this, minus pi cube by 8 plus pi cube, this is 7 pi cube by 8. Yes. Let's move to next question, question number 4. In question number 4, what they are asking, we have to find the domain of fx equal to cos inverse x cube by 2 plus root sine inverse log 2 x plus 1. Now we have to apply all the necessary conditions. Since this quantity is inside cos inverse, so this has to be between minus 1 and 1. So in fact, x cube has to be range from minus 2 to 2. So since x cube graph you all know like this, okay, so if x range is from minus 2 to 2, so x, we can write x would range from minus 2 raised to 1 by 3 to 2 raised to 1 by 3. So this is your condition 1. Now let's apply next condition. Since all these things are inside the square root, so this has to be positive. So when sine inverse will be positive, so its input thing, that is log has to be from 0 to 1 actually. Okay, so if log x plus 1 base to 2, this is from 0 to 1, so this should range from 2 raised to 0, which is 1, to 2 raised to 1, which is 2. So x should range from 0 to 1 actually. Okay, and clearly in this case log argument is also positive, so log doesn't have any problem. Okay, so this is your condition 2. If we take c1 intersection c2, so obviously if we see this 2 raised to 1 by 3, its value would be obviously greater than 1. If we take it the intersection of the two, x would be 0 to 1 actually, because this is a negative thing and this is 0, and out of 1 and 2 raised to 1 by 3, 1 is smaller. Okay, so this is your required range. If this is our required range as per the problem, so a is 0 and b is 1. So what is a plus 2b? Its value is 2 actually. Now let's move to next question, question number 5. In question number 5, sine inverse sine x is taking value pi minus. Now they are asking in which interval this will happen. So you can observe this through the graph of sine inverse sine x very easily. Sine inverse sine x graph looks like something like this. So this is the pi and this is pi by 2. As you can see, what is the equation of this branch? What is the and this is pi by 2. What is the equation of this branch? This is y equal to pi minus x. Okay, so clearly x should, in what branch sine inverse sine x can be equated with this? So pi by 2 to 3 pi by 2 actually. Okay, yes. Now let's move to next question. In question number 6, if you see question number 6, yes, again this is a boundedness question. Sine inverse a whole square cos inverse b whole square plus sec inverse c whole square plus cosec inverse d whole square, this is equal to 5 pi square by 2. Okay, so obviously if we see the uppermost boundary of LHS side, since sine inverse maximum value is pi by 2, so pi square by 4, cos inverse maximum value is pi, sec inverse is also pi, and cosec inverse is again pi by 2. So maximum value of LHS is pi square. If you calculate this, this is 5 pi square by 2. So LHS is actually attaining its maximum value. This can happen only in one case, when all simultaneously will attain its maximum value. This will happen when sine inverse a would be equal to pi by 2. When this will happen when a equal to 1, b equal to minus 1, because cos inverse b is pi when b is -1, c equal to -1 and d equal to 1. Now what they are asking? They are asking sine inverse a whole square minus cos inverse b whole square plus sec inverse c whole square minus cosec inverse d whole square. Now if you put all these values, this is going to be pi square. Obviously this sign will change and this sign will change only. Okay, so minus pi square plus pi square minus pi square by 4. Okay, so everything will get cancelled and final answer would be 0. Now let's move to question number 7. In question number 7, they have given x raised to 5 plus x4 plus x cube plus x square plus x plus 1 less than 0. And they are asking some value. So obviously it's a GP series. We can write this x raised to 6 minus 1 upon x minus 1 negative. So if we factorize the numerator again, so x square minus 1 into x4 plus x square plus 1 divided by x minus 1. So we can cancel this, is this can't be 0. So x plus 1 into x4 plus, obviously if you see, this is always positive. This is always positive. Yes. Now we can say x would be always less than or equal to -1 actually. Okay. And this is saying x can't be equal to 1, and in this range x equal to 1 is not lying. Now what is our desired thing? 2 tan inverse x plus sine inverse 2x upon 1 plus x square plus pi. Now you must have studied one identity, guys. Okay, this is the you have to remember some of the formulae directly in order to save your time. Okay, so you must have studied one thing. So in case x is less than -1, in case x is less than -1, so this can be written as minus pi minus 2 tan inverse x. You can remember this identity directly. Sine inverse 2x upon 1 plus x square. This is equal to pi minus 2 tan inverse x when x is from 1 to infinity. Okay, 2 tan inverse x when x is from -1 to 1, and minus pi minus 2 tan inverse x. You can also prove this, or you it's better you remember this directly. Okay, this and this would be cancel, and this would also be cancel. So final answer would be 0. Okay, now let's move to next question. Our next question is question number 8. Yes, in question number 8, yes, in question number 8 we have alpha equal to 1 by 3 sine inverse 2x upon 1 plus x square, 1 plus x square, and plus 1 by 3 cos inverse 1 minus x square upon 1 plus x square. Okay, so what they are saying, x is greater than or equal to 4 by 3. So obviously x is greater than or equal to 1. We just have seen what this can be written, in case of x greater than or equal to 1. This can be replaced by this. So 1 by 3 into minus pi minus 2 tan inverse x actually. Okay, plus again, if you will also solve this, I am writing the formula for the same cos inverse 1 minus cos x square by 1 plus x square. If you will simplify this, you can also write this is 2 tan inverse x in case x is greater than or equal to 0, and this is minus 2 tan inverse x when x is less than 0. So since x is greater than 1, we can directly apply the formula. This is 2 tan inverse x. Now, what is your final answer? Your final answer would be yes. So sine inverse, no. Since here x is greater than 1, so we have to apply this thing here. So pi minus 2 tan inverse x. So this should be plus here. So this is actually pi by 3. So if alpha is pi by 3, what they are asking? They are asking about cos of 2 alpha. 2 alpha means 2 pi by 3 plus sec alpha, sec pi by 3 plus 3 root 3. by root 3. So sec cos 2 pi by 3, obviously it's minus 1 by 2 plus 2 plus 3 root 3 by root 3. After simplification, you can easily see this is 3 plus 3 by 2 root 3. So which is actually 3 plus root 3 by 2. Now let's move to next question. In next question, question number 9, they have given x cube plus 3x minus tan 2 equal to 0. Now, if you see tan 2 means 2 radian actually. 2 radian means 57 into 2 approx 10114 degree. So obviously its value is negative. So this is it means if tan 2 is negative, minus tan 2 will be a positive quantity. This is a positive quantity. If this is a positive quantity, what is my claim? My claim is its root can't be positive. Why its root can't be positive? Because if all will be positive quantity, then how this can be equated with 0? It means its root will be negative. This is for sure. It means alpha is negative. So if alpha is negative, you must have studied, guys, one thing. So if alpha is negative, cot inverse 1 by alpha can be directly replaced with pi plus tan inverse alpha minus pi by 2. So this is pi by 2. Actually, this we can cancel. So final answer is pi. Okay. Now let's move to next question. Question number 10. In question number 10, we have a equation tan inverse x upon 1 minus x square plus tan inverse 1 by x cube equal to 3 pi by 4. We have tan inverse a plus tan inverse b formula. Now first check what is if this is a and if this is b. So can you tell me what is ab actually? So ab is x into x cube into 1 minus x square. So this is 1 by x square into 1 minus x square. Now if you see very carefully, since they have given x is ranging from 0 to 1, so this is a less than 1 quantity and this is also less than 1 quantity. See, its overall value would be greater than 1. Now remember the formula, when a b is greater than 1, what we can apply formula here? We can apply pi plus tan inverse a plus b. A plus b means this plus 1 by x cube upon 1 minus ab. Ab means 1 upon x square into 1 minus x square. So 3 pi by 4. If you would simplify this, so after simplification, you will get tan inverse. This is minus 1 by x actually. So this is 3 pi by 4. So tan inverse minus 1 by x is minus pi by 4. So this can happen when minus 1 by x is equal to minus 1. So when x is equal to 1. But what they have given us interval of concern, our interval of concern is only 0 to 1 open. So obviously this solution we have to reject because 1 is not included in that interval. Okay, so there is no solution in this case. Now let's move to next question, question number 11. In question number 11, guys, in question number 11, they have given, in question number 11, yes, we have an infinite series whose general term is Tn. Cosec inverse root n square plus 1, n square plus 2n plus 2. Okay. Now, since we know we can create difference in tan inverse series, let's first convert cosec inverse into tan inverse. So cosec inverse this by 1. So what this should be? Cosec inverse inside thing, it should be, it means this is base and this is hypotenuse. This is base and this is this is hypotenuse and this is base. Now tan inverse, it means we have to find out perpendicular. What is perpendicular? Root n square plus 1 into n square plus 2n plus 2 minus 1. If you calculate this, guys, if you expand this after multiplication, this is going to be n4 plus 2n cube plus 3n square plus 2n plus 1. Now, if you see carefully, this can be very easily written in perfect square. How? This is n square whole square plus 2 into uh, n square into n plus 1 plus 1 whole square. You can expand and you can observe this. So this is no, not like this. Or you can observe this very easily, guys. You can observe this very easily. What is this thing? This is nothing but expansion of n square plus n plus 1 whole square. So this is n square plus n plus 1 actually. So tan inverse is P by H. So P by B, sorry. So this is 1 by n square plus n plus 1. Okay. Sorry, in cosec inverse, this is perpendicular, I think. Yes. So this would be your base. Yes. Yes. So tan inverse this. So if we apply the infinite series on this, so this is tan inverse 1 by 1 plus n into n plus 1. And we can obviously break this like n plus 1 minus n equal to 1 to infinity. Now let's break this into two series, tan inverse n plus 1 minus tan inverse n. So clearly this is a telescopic series. Infinity you put inside this, 1 you put inside this. So this is pi by 2 and this is pi by 4. So its final answer would be pi by 4. Now let's move to next question, question number 12. In question number 12, we have a equation to solve. 2 sine inverse root x square plus x plus 1 plus cos inverse root x square plus x is equal to 3 pi. Okay. So obviously, if you see here, can we convert this? Uh, can we apply some formula here? We can write this 2 into pi by 2 minus cos inverse root x square plus x plus 1. And we can again apply a formula here, pi by 2 minus sine inverse. Okay, sine inverse root x square plus x. So this is 3 pi by 2. Obviously, if you will expand this, 2 cos inverse root x square plus x plus 1 plus sine inverse root x square plus x, this will be equal to 0. So obviously its input quantity is positive. So both has to be greater than or equal to 0, and this also has to be greater than or equal to 0. This can be happen only in one case, when x square plus x would be equal to 0, when this sine inverse would be equal to 0. So this would be equal to 0 when x square plus x equal to 0, and at this time this will also be equal to 1, cos inverse inside thing. So cos inverse would also give output 0. So what is this? X into x plus 1 equal to 0. So x is equal to 0 and minus 1. You can check whether both are acceptable solution or not. If you check, both are our acceptable solution. So what is sum of solution? Sum of solution would be 0 minus 1 minus 1. Okay. Now let's move to next question, question number 13. In question number 13, yes, in question number 13, in question number 13, we have cot inverse x plus cot inverse y is equal to cot inverse z. Okay. So if we apply the formula first, since x, y, and z all are natural number, obviously it's positive, so we can apply formula directly. So tan inverse 1 by x plus tan inverse 1 by y is equal to tan inverse 1 by z. Now, since x and y both are natural numbers, so clearly its product would be less than 1. So we can again apply the formula tan inverse a plus b. So 1 by x plus 1 by y upon 1 minus xy. This is equal to tan inverse 1 by z. So let's equate the two sides directly. So this is x plus y. If you simplify this, x 1 up minus xy, this is equal to 1 by z. So clearly, if you do cross multiplication, xz plus yz, this is equal to 1 minus xy. So if this is equal to this, so if I would collect x term, so this would be y plus z, I think. Y x term, if we collect, or what we can do here. So here I think here we have committed a mistake here. So this should be, yes, xy minus 1 actually. So xy minus 1. So if you collect x on one side, so this is xy minus z equal to yz plus 1 actually. So x we can write this yz plus 1 upon y minus z. See, now we have to look for its solution. If I will select y and z as two consecutive integers, if z is some integer n, and y let's say n plus 1, obviously this will again be a natural number. Okay, now clearly in this case you can see n square plus n plus 1. Now these three triplets, n square plus n plus 1 comma n plus 1 comma n. Okay, so this is your x, this is y, and this is z. This will always satisfy the desired equation, and obviously there are many such possible triplets. Okay, so we see its answer would be infinite. Now let's move to next question, question number 14. In question number 14, they have given sine inverse x minus 1 plus cos inverse x minus 3 plus tan inverse x upon 2 minus x square. This is equal to cos inverse k plus pi. Okay, okay, now we have to first apply the condition. Okay, since whatever thing is inside sine inverse, this has to range from minus 1 to 1. Whatever thing is inside cos inverse, this has to range from minus 1 to 1. So here x range would be, here x range would be from minus 1 to 1 actually, sorry, 0 to 2 actually, yes. So here from this x range would be 2 to 4. If you find intersection of the two, obviously there is only one value of x is which is going to satisfy this. So x value, clearly x is taking only one value, so let's put inside the equation. So the equation would be sine inverse 1 plus cos inverse of minus 1 plus tan inverse of 2 by minus 2. So what is the value of this? Pi by 2 plus pi minus pi by 4. So its value would be pi plus pi by 4. So obviously pi plus cos inverse 1 by root 2 actually. So obviously what is the value of, what is the value of k? 1 by root 2. Now let's move to next question, question number 15. In question number 15, question number 15, yes. In question number 15, they are asking about finding the range of one function. So if you have to find the range of this function, this is sine inverse ln greatest integer of x plus ln sine inverse of greatest integer of x. Now we have to apply the condition accordingly. So whatever thing is inside sine inverse, this has to range from minus 1 to 1. So here greatest integer should range from e raised to minus 1. It means 1 by e to e. This is your condition number 1. Now whatever thing is inside ln, this has to be, this has to be sine, this has to be positive actually. But since sine inverse itself can't take value beyond 1, so this is our desired quantity. So here also x can take value from 0 to pi by 2. Now this is your condition 2. Now if you take intersection of both conditions, see, pi by 2 approx value is 1.57 and e is 2.71. Now and 1 by e would be something positive. If we take intersection of the two, so greatest integer of x should lie from 1 by e to pi by 2 actually. So which is the only integer belonging in this interval? Obviously greatest integer of x is equal to 1, because greatest integer x is actually an integral value. So what is the range? Since only this is the possible value of greatest integer of 1, if we will put, so sine inverse ln 1 plus ln pi by 2. So obviously ln 1 is 0, sine inverse 0 is 0. So only one value is possible in range, which is ln pi by 2. Okay. Now let's move to next question, question number 16. In question number 16, we have to find the maximum value of this fx equal to tan inverse. So root 12. So root 12 we can write 2 root 3 minus 2 x square upon x4 plus 2x square plus 3. We have to find maximum value of it. Let's interpret first. What is the, now can we shift this x square in the bottom side? If we divide to bottom side, so this is x square by 3 by x square plus 2. Now we can apply AMGM inequality on this. So if we apply AMGM inequality, since both are positive quantities, this by 2 equal to product of the 2 power half. So obviously its value would be greater than or equal to 2 root 3 actually. It means its maximum value is 2 root 3. So obviously this whole thing would be less than or equal to actually, so 2 into root 3 minus 1. If we replace by this 2 root 3, which is its maximum value, we can write like this. So obviously if you simplify this, so root 3 minus 1 upon root 3 plus 1. So let's rationalize this. So this is root 3 minus 1 whole square by 2 actually. So if you will open this 4 minus 2 root 3 by 2, which is 2 minus root 3. You have to take tan of this. So obviously tan inverse is an increasing function. So if tan inverse is an increasing function, if input will be maximum, so output would also be maximum. But its maximum value 15 degree actually. Okay. Now let's move to next question, question number 17. Question number 17. Yes. Question number 17. In question number 17, what they are saying, they have redefined sine inverse actually from minus 1 to 1 to pi by 2 to 3 pi by 2. They have redefined actually. Okay. And cos inverse, they have also redefined minus 1 to 1. This will take input and this will give output 0 to pi. Okay. So we have to work according to this. So what they are saying, cos inverse x plus sine inverse x, this will be equal to what? Let's check this at some value. So let's put x equal to 0 in this. If you put x equal to 0, so sine inverse 0 plus cos inverse 0. See, sine inverse 0, we cannot write 0 here because what is our range? Our range is from pi by 2 to pi 3 pi by 2. So where sine is 0 actually in this range, so actually this is pi, because sine pi is 0, so sine inverse 0 is pi, according, because we have to work according to this principal range. So what is cos inverse 0? Which is pi by 2, because pi by 2 is in this range. So this is 3 pi by 2 actually. So let's check for one more value, let's say. So for x equal to 1, if we will check, so sine inverse 1 plus cos inverse 1. So can you imagine any one value where sine is giving value 1 in between? Obviously it's pi by 2. So cos inverse 1 is, it's actually 0. So can you see these two are itself not uniform? How we can claim this is a constant function? So its value would obviously, we cannot say this is not a constant. Yes, not a constant. So its value changing. Now if you will put some other value, x equal to 1 by root 2, this will give you another value. Okay. Now let's move to next question, question number 18 actually. Question number 18. Yes. In question number 18, what they are saying, in question number 18, what they are saying, there is a function fx tan inverse 3x square plus bx plus 3. X is ranging from 0 to pi by 2. So here pi by 2 open. Yes. So obviously tan inverse is taking, tan inverse is how is the graph of tan inverse? This is the graph of tan inverse. When tan inverse is will take a no, sorry, this is range, it means fx range from here. So if fx is positive, obviously its input would also be positive. This should be positive. Yes, this should be greater than or equal to 0. So if this is greater than 0, obviously its output would be greater than 0. So when this will be greater than 0 for all x belongs to R, so obviously this is a upward parabola actually. So this is upward parabola, its leading option is positive. So this can happen in only one case, when discriminant is less than or equal to. What is the discriminant? B square minus 4ac, B square minus 36 less than 0. So B should range from minus 6 to 6. So what are the integral value in this range? Minus 6, minus 5, 0, 1, 2, up to 6. So what is the sum of all possible value of B? Sum of all values of B. So obviously, if you will add all the values, this will vanish. Okay, this is equal to 0. Now let's move to next question, question number 19. Question number 19. Yes. So in question number 19, we have tan inverse. Question number 19, we have tan inverse. Yes. So tan inverse is this question number 19 we have. Okay. It means Okay, question number 19. Okay, let's see question number 19. Tan inverse. Yes, this is the question. Tan inverse 1 plus x square divided by minus 1 minus x square upon 1 plus x square plus 1 minus x square. This is equal to alpha. Then x square is equal to actually x square is equal to, now if you see this question, so we can shift we can shift tan that side. This is tan alpha. Okay, now let's use componendo and dividend. If you use componendo and dividendo, let's add these two first. If you add these two, this would, let's do denominator minus numerator. This is going to be 1 minus x. So if this is 1, let's add this first and let's subtract this. Okay, this would be like this. 1 plus x square upon 1 minus x square. This is surely going to be square of this one actually. So square of this. So 1 plus tan alpha. So which is, we can also write like this. Okay, so like this. So this is tan pi by 4 plus alpha actually. Okay, now we have to find x square actually. So let's use again componendo and dividend. If we use again componendo and dividendo, let's subtract first now. If we subtract, this is going to be 2x square. If we add, this is going to be 2. So this is 1. Let's subtract first. So if we do subtraction, this is tan pi by 4 plus alpha minus 1 divided by addition. Addition would be 1 plus tan pi by 4 plus alpha. So 2 and 2 would get cancelled. So this is x square is equal to, okay, so if we will rewrite this, so this is again, okay, we can write this. Yes, this one we can write. So this is tan pi by 4 actually, tan a minus tan b plus tan a into, yes, this one we can replace with tan pi by 4 actually. So we can again write tan pi by 4 plus alpha minus pi by 4. Yes, so this is x is equal to, actually x square is equal to tan alpha, we can say. So x equal to, so, oh, they are asking actually, yes, they are asking actually, so x square should be equal to tan alpha actually. Why our such thing is coming like this? Oh, yes, yes. mm, oh, there should be some square here. Yes, there should be squaring here, this side. Okay, here we have missed something. Okay. Yes, let's delete all these things. We have missed squaring here. Yes. So this is tan pi by 4 plus alpha. This is square actually. So this is by 1. Okay. So, or we can also open this one. Okay. So if it's square, so this is going to be 1 plus tan square alpha plus 2 tan alpha divided by 1 plus tan square alpha minus 2 tan alpha. Now let's use now componendo and dividendo. If we use componendo and dividendo, if we subtract, so 2x square, if we add 2, so let's subtract this. If you subtract this, this is 4 tan alpha, and if you would add, so this is going to be 2 into 1 plus tan square alpha. So obviously this 2 can be cancelled, so x square can be equated with tan 12. Yes. Now let's move to next question, question number 20. In question number 20, tan inverse root x square plus 1. Tan inverse root x square plus 1. Okay. Yes. Tan inverse x square plus x plus sine inverse root x square plus x plus 1 is equal to pi by 2. Now, if we see from here, can we convert this in cos inverse so that sine will be best compatible with cos inverse, I think. So if we try to find out tan inverse into cos inverse, so this is x square plus x by 1 actually. So what is the cos inverse? Cos inverse b by h. If you would try to find out 1 by root x square plus x plus 1, because this is p and this is h, this is b. So cos inverse b by h would come. So b is 1 and h you can find out. So plus sine inverse root x square plus x plus 1. Now since sine inverse something plus cos inverse something, these two has to be equal. So if we equate the two, this is 1 by root x square plus x plus 1 and do cross multiplication. So x square plus x should be plus 1 should be 1. So x square plus x would be 0. So x will be having two values, 0 and minus. So obviously you can check these two value also. If you put 0 in the, you can see the LHS after putting 0. So this is 0 plus pi by 2, which is equal to pi by 2. Yes, this is okay. You can also check with minus 1. So 0 plus pi by 2, I think. Yes. So this is equal to pi by 2. This is also okay. Both are acceptable solution. It means two solutions. Two solutions. Yes. Now let's see next question, which is numerical answer type question. Question number 21. In question number 21, which is a numerical answer type question. Okay. So in this question, we have 3 tan inverse, 3 into tan inverse 3 sine 2 alpha by 5 plus 3 cos 2 alpha. Okay. Plus tan inverse tan alpha by 4. So how to solve this? Okay. Now we can solve the first part actually. Now let's open this. We can write this is 6 sine alpha cos alpha, because sine alpha I am writing 2 sine alpha cos alpha. And let's break this 3 into, can we write like this? Yes. And 1 plus 2 cos alpha again can be written as 2 cos square alpha. Okay. So plus tan inverse tan alpha by 4. Okay. Now if we write, if we divide by cos square alpha both in the numerator as well as denominator, and we can cancel 2 also. So this will be 3 tan alpha divided by 4 plus tan square alpha actually, or you can write like 3 plus sec square alpha. Okay, if we divide by cos square alpha in the numerator as well as denominator and cancelling the 2. So this is tan inverse tan alpha by 4. Okay. Now we can replace this cos sec square alpha as 1 plus tan square alpha. So this would be finally, so our numerator would be 4 plus tan square alpha. Let's divide by alpha by let's divide by 4 simultaneously. So this would be 1 plus tan square alpha by 4. Yes, just tan square tan inverse tan alpha by 4. So now if we try to break tan inverse, so we can write this tan alpha minus tan alpha by 4 actually. So this is 1 plus tan alpha into tan alpha by 4. Okay, plus tan inverse tan alpha by 4. Yes. So now we can apply the formula of tan inverse. So tan inverse tan alpha minus tan inverse tan alpha by 4. Okay, plus tan inverse tan alpha by 4. Okay, so we can cancel these two. So tan inverse, since alpha what they are saying is alpha is 2 by 3 actually. So 2 by 3 actually is a uh, actually 2 by 3, which is less than, if you see, less than pi by 2. So tan inverse tan alpha can be written as 3 alpha. So 2 into 3 by 2, which is actually 2. Now let's move to next question, question number 21. In question number 21, yes. So we have to find sine of 2 sine inverse root 5 by 3 minus cos inverse root 5 by 3. Okay, this we need to find. Now, so we can convert obviously this into one thing. So pi by 2 minus cos inverse 5 root 5 by 3 we can write. So this is pi by 2 minus 2 cos inverse root 5 by 3. Now let's open this. This is pi minus 4 cos inverse root 5 by 3. So this is sine, pi minus theta is sine theta actually. So 4 cos inverse root 5 by 3. Now we want to apply the formula of sine 2 theta actually. So 2 into sine theta. So sine 2 cos inverse root 5 by 3 cos 2 cos inverse root 5 by yes, cos 2 cos inverse root 5 by 3. Can we break this again? Yes, 2 sine cos inverse root 5 by 3 cos inverse root 5 by 3. Can we again break this second part? Can we again break this? Yes. So we can apply the formula 2 cos square theta minus 1. Cos inverse root 5 minus 1. We can apply the formula. Now let's solve this. Let's put all the value one by one. So this is 4 into. Now can we convert this cos inverse into sin inverse? Yes, this is B and this is H. We can again convert this. This would be 2 by 3. You can check this 2 into, sorry, into product into, I think, yes. So what is this cos 2 of this? So 2 into, what is this? Cos square of cos inverse root 5 by 3. This is 5 by 9 actually, minus 1. If you simplify this, you will get your answer 8 root 5 by 81. So obviously K answer is 8. Okay. Let's move to next question, question number 23. In question number 23, okay, in question number 23, they have written one expression, okay, fx, they have written like fx, they have written like 3 by 2 sine inverse 2x by 1 plus x square plus 3 tan inverse x greater than 1. 3 pi by 2 into x if x is from minus 1 to 1. And what they have written more, cos inverse 1 minus x square upon 1 plus x square plus 2 tan inverse x minus 3 pi by 2 if x is less than minus 1. Okay. Now, if you try to simplify this, as I have written the result actually, I have written the result earlier. So, if x is greater than 1, okay, you can directly use the result sine inverse 2x by 1 plus x square can be written with, it can be replaced with, so pi minus 2 tan inverse x. Similarly, this can be replaced if x is less than minus 1. If x is negative, this can be replaced with minus 2 tan inverse x actually. So if you would simplify this after putting this, so your function would be 3 pi by 2. This is a constant function x greater than 1. So 3 pi by 2 into x minus 1 to 1 and minus 3 pi by 2. So if x is less than minus 1. Now, if we try to make its graph would be something like this. 3 pi by 2 into x, obviously it's a line passing through origin at 3 pi by 2 level and at minus 3 pi by 2 level. Yes. Now what they are asking, what area from this is 1 and this is minus 1. They are asking what area from minus 2 to 2. Minus 2 to 2, they want to know about this area. Yes, this area they want to know. How to find? So double we can do. So what is this triangle area? This triangle we can find half into base into height plus this rectangle area, which is 3 pi by 2. Okay. So if you simplify this, this is going to be 9 pi by 2. So obviously P value is 9 and Q value is 2. So what is P minus Q mod? This is 7 actually. Okay. Now let's move to next question, question number 24. In question number 24, Yes, in question number 24, we have a question sine inverse sine mod x. This equals cosec inverse minus log x by pi. Okay. Now, first of all, they have given what is the x range minus pi by 2 to pi by 2. So in pi minus pi by 2 to pi by 2, so sine inverse sine obviously behave as x. So obviously we can take out mod x very easily. So cosec inverse of something we can write sine inverse of. We can reverse this. It means minus 1 by log x by pi as base and 2 as argument. We can rewrite this as so minus log x by pi to the base 2 actually. So this is mod x. Okay. Now if you see this very carefully, since x is ranging from minus pi by 2 to pi by 2, so x by pi would range from minus 1 by 2 to 1 by 2. So if we take log na, obviously we cannot take log of negative part. So 0 to half, we can, if we take log, so this is going to be minus infinity to minus 1 actually. So minus log 2 x by pi, this would be always greater than 1. If this is always greater than 1, this is not acceptable. Okay, sine inverse won't accept it. Okay, so not in domain of sine inverse x. If this is not in domain of how this can be equated. Okay, so no solution from here. Now let's move to next question, question number 25. In question number 25, yes, in question number 25, in question number 25, yes. So in question number, yes, 25, we have 3 sine inverse 2x upon 1 plus x square, okay, minus 4 cos inverse 1 minus x square upon 1 plus x square plus 2 tan inverse 2x upon 1 minus x square pi by 3. Now, I have used this formula today multiple times, okay. Since x is positive, since x is greater than or equal to 0, so but still we have to make two cases within this. Okay, so if x is from 0 to 1 and if x is from 1 to infinity. Okay, so if x is from 0 to 1, we have seen how we can break this. How we can break this? We can break this like 2 tan inverse x, like this directly. How we can break this? We can break this is again as 2 tan inverse x, and that again as 2 tan inverse x is equal to pi by 3. So this is 2, if you simplify this, 2 tan inverse x equal to pi by 3. So tan inverse x is equal to pi by 6. So x equal to 1 by root 3. Should we accept this? Of course, since this is positive as well as less than 1, accept it. Yes. Now let's deal this in another case. If x is greater than 1. Now how we can break the first? Sine inverse 2x upon 1 plus x square can be replaced with pi minus 2 tan inverse x. Another one we can replace with 2 tan inverse x, and third one we can replace with 2 tan inverse x minus pi. Okay, so this is equal to pi by 3 actually. Okay, so what formula I am using? Earlier two formula I have written already. Okay, so tan inverse formula I am writing here. Remember this directly: tan inverse 2x minus 1 minus x square. This can be opened in three cases: 2 tan inverse x minus pi if x is greater than 1, 2 tan inverse x if x is from minus 1 to 1, and 2 tan inverse x plus pi. Obviously, we cannot include 1 because this is not in domain. 2 tan inverse x plus pi. So if x is less than minus 1, I am using this formula. Okay. So since x is greater than 1, I have written this segment here. Okay. Earlier two results I have written already in the earlier problems. So if you simplify this, this is going to be tan inverse x as pi by 15. Okay, so x would be 10 pi by 15. Obviously, its value would be less than 1. So this we have to reject actually, which is 2 minus root 3 I. No, no, no. Whatever is this value, since 15 is less than 45 degrees. Okay, so we have to reject that value. Okay, so this is rejected actually. So we have only one solution in this case. Okay. Now let's move to next question. Next, our next question is question number 27. Our next question is question number 26. Sorry. In question number 26, yes. So, so we have to find the solution of sine of 2 cos inverse. Cot 2 tan inverse this equal to 0 actually. So when this will be 0, sine inside sine thing is 0. So this has to be this has to be actually equal to n pi. So if this is equal to n pi, cos inverse cot of 2 tan inverse x, this has to be n pi by 2. N pi by 2 means minus pi by 2. Let's put value n minus 1, 0, pi by 2, pi 3, pi by 2. As we can see, this is outside cos inverse range. This is also outside this these three value can be possible. So we can write if cos inverse take value 0. So this will take value 1. If this is pi by 2, this will be 0, cos pi by 2 0, and this is minus 1. So 2 tan inverse x, we can write. So if this is 1 actually, so this is pi by 4. This is pi by 4. Okay. Then this is pi by 2 and this is 3 pi by 4 actually. Okay. So 3 pi by 4. And obviously, if you see 2 tan inverse x, so 2 tan inverse x can range from where to where? Minus pi to pi actually, because tan inverse range is from minus pi by 2 to pi by 2. So obviously cot can take value negative also. Okay, so tan inverse x can be pi by 8 plus minus pi by 4 plus minus 3 pi by 2. Obviously there are 6 values of tan inverse x, and tan inverse x is an increasing function, so x will have 6 different values. I'm not calculating value, and in question they are not asking to. Okay, so we have to just say how many values of x can be there. Okay, so there are 6 values of x. Now let's move to next question, question number 27. In question number 27, yes, so they have written an infinite series, not infinite series, sigma r equal to 1 to 50. So tan inverse, what they have written, this is 2r upon r4 plus r square plus 2 actually. So this is r equal to 1 to 50 tan inverse. If you try to break this, you can break like 1 plus r4 plus r square plus 1. And you can again factorize this. Directly remember its factorization. This is r square plus r plus 1. This is r square minus r plus 1. We can write numerator as difference of the, like this. We can write like this. Okay. Now let's use the sign difference formula. How we can write this? This is r square plus r plus 1, and this is tan inverse r square minus r plus 1. Okay. So obviously this is a telescopic sum. If you try to break this, this is 1 plus r into r plus 1. Okay. And this is 1 plus r into r minus 1. So obviously it's telescopic thing. If this whole thing is function of r, this whole thing is function of r minus 1. You can put 50 inside this and 1 inside this. So this is tan inverse. If you put 2551 minus tan inverse 1 actually. So if you would simplify this, tan inverse a minus b 2550 upon 2552 actually. So if you would solve this, 1275 1270, obviously two consecutive natural number would always be co-prime. So what is its difference? Its difference is 1x. Now let's move to next question, question number 28. In question number 28, again we have a tan series problem. So let this sum be s. So this is 2 by pi sigma n equal to 1 to infinity. So tan inverse 8n divided by n4 minus 2n square plus 5. So what is this? 2 by pi n equal to 1 to infinity tan inverse. Now how to break this? How to break this? See, can we express this like this? N square minus 1 whole square plus 4 actually. Now let's divide by 4 actually first. So 1 plus n square minus 1 whole square by 4 this is. Now how we can break this? We can break this as n plus 1 by 2 minus into n minus 1 by 2, or we can break this like n plus 1 whole square by 2. Yes, n minus 1 whole square by 2. So is our numerator actually a difference of this? You can check. Yes, this is difference of this. Yes, this is difference of this. Now if you break now, this will be tan inverse n plus 1 whole square by 2 minus tan inverse n minus 1 whole square by 2. So just put infinity here and 1 here. So this will be pi by 2 and this will be 0. So your answer would be 1 actually. Now let's move to next question, question number 29. In question number 29, we have a function x square minus cos inverse cos k raised to power half x is 1 by 4 mod k minus pi. Okay, so yes. Now what they are asking, this should be having two different solution. This, if this quadratic is having, should be having two different root, it means its discriminant has to be negative actually. If its discriminant, sorry, if its discriminant has to be greater than or equal to 0. Yes, because both can be same also. It may its roots should be real actually. So let's put discriminant condition. So cos inverse cos k whole square minus 4. So mod k minus pi. This should be greater than or equal to 0. So k minus pi. This should be less than or equal to. Sorry, this is 2 into half. So this would be like this. So cos inverse cos k. Now obviously we have to solve this. We have to make the graph of the two. So obviously, let's suppose instead of k there is a x. So we know the graph of cos inverse cos, which looks like something like this. Okay, like this. Now how is the graph of mod k minus pi? Obviously, this is what? This is pi. This is 2 pi. This is 0. Mod k minus pi graph would be something like this. Okay, something like this. So where this will intersect? This will intersect in between. You can solve the two equation also. This is y equal to x and this is y equal to uh, x minus pi actually. So if you solve this two, this is pi by 2 and this is 3 pi by 2. And I want this curve should be below this curve. So which is only possible in this range. Which is only possible in this range. So obviously k should range from pi by 2 to 3 pi by 2. So what are the integral value of k in this range? What is this? 1.57. And what is this actually? This is 4.71. If you, so k value is 234 actually. Okay, so these are your possible values of k. Okay, so this is question number 29. This, now let's move to next question, question number 30. In question number 30, this is sine inverse x plus cos inverse x plus sec inverse z. This should be greater than or equal to t square minus root root 2 pi into t plus 3 pi. Okay, so find the value of this. Okay, now again, if we check the left boundary of this one, what is the maximum value of this? This is pi by 2 and this is pi and this is pi again. So what is this? This is 5 pi by 2 actually. So what is the minimum value of this? Minimum value of this. So minimum value of this is actually minus d by 4a. So minimum value of this is minus d by 4a. So what is minus d by 4a? So 2 pi minus 12 pi by 4h. So this is 5 pi by 2. So its maximum value is 5 pi by 2, its minimum value is 5 pi by 2. It means this can happen only in one case, when both are equal actually. And when both would be equal, when sine inverse x would be pi by 2, when x is 1, when cos inverse y would be pi, when y would be minus 1, and when sec inverse z would be pi, when z would be minus 1 actually. And when RHS would be equal to that, when t will take value minus b by 2a. So minus b by 2a. So this is like this, minus b by 2a. Yes. So what is the t value? Root 2 pi by 2 actually. So what they are asking, sec of pi by 4 actually, plus minus pi by 4, plus minus pi by 4, plus 10 of that. If you would find out that that is actually also pi by 4. So these all things would be cancelled. 6 0 would be 1 actually. Now let's move to next question. In question number मनाली में मुझे 5-10 मिनट लेट हो सकते हैं तो मेरा है मैम बस 5 मिनट मुझे लगेगा है ना मेरा एक क्लास है 3 घंटे का है उनको बोलिएगा 5 मिनट्स डिस्ट्रीब्यूट करके 5 मिनट्स से मैं आता हूँ सिया मैम एक को मैम बोल दिया मुझे 5 मिनट लगेंगे रिकॉर्डिंग में मेरे रूम में डिस्ट्रीब्यूट करके मेरा है मैम बताता हूँ C2 में मैम हाँ C2 5 मिनट्स में मैं आता हूँ now let's move to next question number 31 in question number 31 yes we have next question number 31 okay so in question number 31 we have a function fx sine of sine inverse 2x this cosec of cosec inverse 2x this tan inverse 2x. Obviously, if we try to find out domain of this function, so 2x, since this is present inside sine inverse, this has to range from -1 to 1. So x should range from -half to half actually. Now, since this thing is present inside cosec inverse, so 2x should belong from -infinity to -1 union 1 to infinity. So x should belong from -infinity to -half union 1/2 to infinity. So what is the intersection of these two? Intersection of these two would have only 2 points, -half and half. Now these 2 points are in its domain actually. Only these 2 points. Now if you see, actually f is a odd function. This is true because f of minus x, if you see, so this if you would put minus here, minus here, all are type 1 function. It means all are odd function actually. So minus will come out. So option number A is correct. Okay. So fx is injective function, one function. It's true because if you find f of minus half, your answer would be sine inverse of f of minus half sine inverse of sine of sine. So you can find out this function also. Wherever it is defined, this can be equated with 2x, and 2x. This is 6x actually because inverse function is outside, inverse trigo is inside. So we can directly remove that. So 6x. So this is -3 actually. So what is f of half? This is 3 actually. Okay. So f of minus half is 3, -3, and f of half is 3. So if we try to plot the mapping of this function, so -half and half, this is -3 and 3. This is actually a 1 function. Okay, so your option number B is also correct. Okay, range of fx is containing only 2 in it, which is true. F dash of half is equal to 6. See, f dash of half, since this function is a point function, okay, which are only defined at half, so we cannot define it in the right neighborhood of half or left neighborhood of half. It means its right hand derivative and left hand derivative won't exist because this is a point function, doesn't exist. That is why f dash doesn't exist. So A is correct, B is correct, C is also correct. So which option is incorrect? D option is incorrect. Okay. Now let's move to next question. Your next question is question number 41. In question number 32 actually. Okay. In question number 32, we have a function x cube plus bx square plus cx plus 1. This cubic function equal to 0 actually. So they want to talk about its root. Okay, this is a cubic equation and where b is less than c. Now, if we suppose this as a function, now first guess Can you comment about its root something? So let's find f of 0. F of 0 is 1 actually. So let's find f of 1. F of 1 would be 2 plus b plus c. We cannot predict our sign of this. Okay. So let's f of minus 1. So f of minus 1, if you find out minus 1 plus b minus c plus 1, this is b minus c. And obviously b is less than c, so this is negative. So if f of 0 is positive, f of minus 1 is negative. So obviously one root would be in between this from intermediate value theorem, as you all know. So obviously x value, whatever it is, its root should be from minus 1 to 0 actually. From minus 1 to 0. Yes. So we need to find out 2 tan inverse cosec alpha plus tan inverse 2 sin alpha into sec square alpha. If you see, this is obviously less than minus 1. How? Because alpha is a negative number. Okay. Alpha is alpha is actually minus 1 to 0. If you see, because cosec range is from, what is the cosec natural range? Minus infinity to minus 1 union 1 to infinity, and here you are giving a negative value inside. So obviously it will take less than minus 1 value. So let's apply the formula here. The formula which I have written here, a formula I have written here, you can use this formula here. Okay. This formula I have written here. We have to use which formula? See, we have to use this formula. Since x is less than minus 1, we want to use this one. So 2 tan inverse x, we can transfer this by that side. So we can write tan inverse 2x upon 1 minus x square minus pi in this case. Okay. When we can use when x is less than minus 1. So I'm using the same formula. Okay. If I will use that formula here, so this we can write as 2 tan inverse, sorry, this we can write as tan inverse 2 cosec alpha upon 1 minus cosec square alpha minus pi. Okay. And again, if you would, we can write this sin alpha sec square alpha h. Now what is this? If you try to simplify this, this is minus 2 by sin alpha into sin square alpha by cos square alpha. Okay. So one sin alpha would be cancelled. So minus pi plus tan inverse 2 sin alpha into sec square alpha. If you see very carefully, this and this is same thing. So these two will be cancelled. Your final answer will be minus pi actually. Okay. Now let's move to next question. Question number 33. If you see next question, question number 33. What is that question? In question number 33, we have to find a, again, infinite series, but this infinite series in terms of sine inverse. This is actually a very good question, guys. Very good. So 2 omega plus 1 omega into omega plus 1 root omega square plus 2 omega plus omega plus omega square minus 1 actually. Okay. Now, if you see very carefully, what is this actually? If you observe, this is nothing but we can write like this: root omega square plus 2 omega whole square minus omega square minus 1 whole square. You can observe this. Now if I would try to factorize this, this is a square minus b square, a plus b into a minus b. So a plus b, one thing would be cancelled. So this would be root omega square plus 2 omega minus root omega square minus 1 upon omega into omega plus 1. Now if we try, see, try to convert in the formula, some formula. If we try to again write this, so this can be written as 2 omega square plus 2 omega upon omega plus 1 into 1 by omega minus root omega square minus 1 by omega into 1 by omega plus 1. Now, you know one formula, sine inverse. Can you, if there should be one observation required here. If this is x, you can very easily observe this is nothing but root 1 minus x square, that you can check. And if this is y, and this is root 1 minus y square, that you can easily check. Now we all know the formula, sine inverse x root 1 minus y square minus y root 1 minus x square. This is going to be sine inverse x minus sine inverse y. Now let's write this sigma omega equal to 1 to infinity sine inverse root omega square plus 2 omega upon omega plus 1 minus sine inverse root omega square minus 1 by omega. Okay, what is this actually? What is this? Omega equal to 1 to infinity. Sorry, this root is only here. Okay, only on this. Yes, so if we try to write this sine inverse, this is omega into omega plus 2, and this is omega plus 1, and this is sine inverse root omega plus 1 into omega minus 1 by omega. So if your observation is sharp, this is, if this is function of omega, this is function of omega plus 1, obviously it's a telescopic series. Let's put infinity in this, in 1 in this. If you put infinity in that, if you put infinity in that, so limit omega tends to infinity sine inverse, if you see carefully na, okay, so this is omega square plus 2 omega by omega plus 1, and if you put 1 inside this, this is surely going to be 0. So if you take limit omega tends to infinity, obviously numerator and denominator both degree is same, so sine inverse 1 actually this will come. So this is pi by 2. Okay, now let's move to next question. Next question means question number 34 actually. Now let's move to question number 34. In question number 34, okay, 34 we have a equation cot inverse x into tan inverse x. That's 2 minus pi by 2 cot inverse x minus 3 tan inverse x minus 3 into 2 minus pi by 2. Now you can easily factorize this. You can very easily observe this. Okay, so you can take cot inverse common from here. You can take 3 minus 3 common out of the last two. So cot inverse minus 3 tan inverse x plus 2 minus pi by 2. Okay, so this is greater than 0. Now if the product of these two are greater than 0, there are only two cases possible. Case 1, when both is positive, cot inverse x minus 3 is positive, and this is also positive. And what is the case 2 possible? Case 2, both is negative, cot inverse x minus 3 less than 0 and tan inverse x plus 2 minus pi by 2, this is also negative. So if cot inverse x is minus 3 greater than 0, it means cot inverse x greater than 3 and tan inverse x greater than pi by 2 minus 2. Okay, pi by 2 minus 2. Now you can see this from the graph also. Okay, so cot, if we take cot inverse x, do you remember the graph of cot inverse x? Graph is like this. Okay, cot inverse x graph is like this. So if cot inverse x is less than 3, if this is greater than 3 actually, so 3 where it would be 3 would be somewhere here. Okay, 3 would be somewhere here. If this is greater than 3, you can very easily observe when this will be 3, obviously at cot 3. Okay, obviously, sorry, oh, okay, so yes, so when this will be when this will take value 3 which is just less than pi at cot 3. So if you want this cot inverse should be greater than 3, it means in this section, okay, if you want this should be in this section, so x should be less than cot 3. Okay, not minus cot 3, cot 3. Okay, x should be less than okay cot 3. Yes, and what this is saying, can you take tan both side? So tan inverse x, so if you take tan both side, tan inverse x is greater than actually pi by 2 minus 2 actually. So can we take tan both side actually? Why I'm taking tan both side? Because I know this is a number from minus pi by 2 to pi by 2. And obviously tan is increasing from minus pi by 2 to pi by 2. So x is greater than cot 2. So and x is greater than cot 2. Now if you see x should be less than or equal to less than cot 3 and x is greater than cot 2. What is the intersection of these two? If you try to take intersection of this, cot 2, see, cot 2, it means cot 114 degree. Cot 3 means cot 57 into 171 degree. If you see, both is a negative number, but cot 114, this is a less negative number. Cot 171 is a more negative number. Okay, so intersection of these two is not possible. X belongs to phi. Now let's investigate in this case. Cot inverse x less than 3. Similarly, if cot inverse x is greater than 3, we have written this. So from this we can write x is greater than cot 3 and tan inverse x less than 2 minus pi by 2. So obviously after taking tan we can write x is less than cot 2. If you try to take intersection here, so here intersection is possible because cot 2 is a less negative number and cot 3 is a more negative number. So obviously its intersection would be cot 3 to cot 2. Okay, match the correct option accordingly. Now I am moving to next question. Now let's move to question number 35 actually. So in question number 35, yes, in question number 5, in 35 we have sine inverse sine. This is a routine question, normal question, plus cos inverse cos 5 pi by 3 plus tan inverse tan 5 pi by 7 plus sine inverse cos 2. Now cos 2. Now how we can find out sine inverse sine? Now let's use the graph of this. Sine inverse sine graph is like this. Then this is 3 pi. Okay, so this is 0 pi. So actually 22 pi by 7. Oh, yeah, this is 22 pi by 7. So this is 2 pi, this is 3 pi. Okay. Now if this is 3 pi, 22, this is 4 pi. So 22 pi by 7 would be somewhere here, just greater than 3 pi. So what we can write the equation of this line? Number minus x. What is the equation of this? 3 pi minus x. So what we can write this? We can write this 3 pi minus 22 pi by 7. Okay. What is cos inverse cos 5 pi by 3? Cos inverse cos 5 pi by 3. This is cos inverse cos graph is something like this. Okay. So 0, this is pi by 2, this is pi. 5 pi by 3. So 5 pi by 3. So this is 2 pi. No. Sorry. Okay. Cos inverse cos graph is, this is pi. This is 2 pi. This is 3 pi. Okay. So 5 pi by 3 would be somewhere here. 5 pi by 3. So this is 5 pi by 3. So what is this branch? Number minus x. So this is 2 pi minus 5 pi by 3. How to find out this? Again, let's again see the tan graph. Tan graph is something like this. Something like this. Where is the 5 pi by 7? This is, I think, pi. So 5 pi by 7 is somewhere here. Okay. So we can write this. This is 5 pi by 7 minus pi actually. Because this is, it's what is its equation? This is x minus number. Okay. Sine inverse cos 2. How you can write this? Pi by 2 minus cos inverse cos 2. And cos inverse cos 2. How do you write this? Since cos inverse cos 2 is a quantity which is less than pi actually. So this will be open as x. So this is 2 actually. So if you try to solve all these things, 4 pi minus 17 pi by 7 minus 5 pi by 3 plus pi by 2 minus 2. If you try to solve all this, you will end up getting 17 pi by 42 minus 2 actually. So what is your correct option? Option number A, I think. Okay. Now let's move to next question, question number 36. In question number 36, in question number 36, yes, question number 36 is, we have, again this is a very easy question of boundedness. Cos inverse x plus cos inverse y plus cos inverse z, this is equal to 3 pi. Okay, obviously cos inverse maximum value can be pi. So obviously all three has to take value pi simultaneously. It means x, y, z all has to take value -1 simultaneously. So what is the x cube plus y cube plus z cube in this case, which is actually -3. Now let's move to next question, question number 37. In question number 37, we have to find out, we have to find out yes, we have to find out sine inverse of cot of sine inverse. This is √2 minus √3 by 4. This is, so by 2 we can write out this. Okay, by 2 plus cos inverse, this is 2 √3 by 4, the sec inverse √2. Okay, sec inverse. So what this is actually, this is whole quarter. Okay, so what is this actually? Let's multiply by √2. This is 4 minus 2 √3, and this is 2 √2. If you see very carefully, if you try to make perfect square of this is nothing but √3 whole square plus 1 square minus 2 √3. So this is root of √3 minus 1 whole square. Okay, plus what is this, cos inverse √3 by 2 plus sec inverse √2. These all value we know very easily. Okay, now sine inverse cot of. Now do you remember the value, guys? So this is sine inverse √3 minus 1 by 2 √2 plus cos inverse √3 by 2 plus sec inverse √2. So what this is nothing but 15 degree actually. This is 15 degree. And what this is 30 degree actually. And what this is 45 degree. So this is actually 90 degree. Okay, sorry, this is cot. So what is cot 90 degree? 0, and sine inverse 0 is 0. Okay, now let's move to next question, question number 38. In question number 38, yes, we have again equation sine inverse x square plus x plus 1 plus cos inverse ax plus 1. This is equal to pi by 2. Okay, and this should be having two solutions. When these two would be equal, when sum of these two would be equal to pi by 2, when these two would be equal actually. So when this is equal to this, let's equate the two. 1 and 1 can be cancelled. Okay, so this should be having two possible solutions. So x is equal to ax. So we can transfer this, that's this side. So x into x plus 1 minus a equal to 0. So here clearly x is having two value. One is 0 and other one is x equal to 1 minus. Okay, sorry, a minus 1. This would be having a minus 1. Yes, this is a minus 1. Okay, this is x equal to a minus 1. Now this is x equal to a minus 1. Now what in question they are saying, both should be distinct actually. If both is distinct, obviously x equal to 0 is an acceptable solution. Okay, if both is distinct, so obviously this should be also acceptable. Okay, so what I am saying, if both should be distinct, a minus 1 should not be 0. So a cannot be 1. If a cannot be 1, can a be higher than 1, 2, 3, 4? Can we take all these things? Obviously not, because if you take all these values of a, then what is your corresponding value of x? Corresponding a value of x, which is a minus 1, 1, 2, 3. If you put here 1, this value, this is not going to be accepted value. Okay, now let's see, can we take a value less than 1? That is 0, minus 1, minus 2. If we take x a value as this, what is a minus 1? This is minus 1, minus 2, minus 3, all these things. Now if you see, is minus 1 okay to us? Answer is minus 1 is okay to us. But is minus 2 okay? Answer is not. If minus 2 is not okay, minus 3 is also not okay. You can check now. After putting this will go outside the range of sine inverse. So only one value is accepted here, and in this case a equal to 0 is only permitted. Okay, now let's move to next question, question number 39. In question number 39, guys, in question number 39, yes, in question number 39 we have, okay, question number 39. Yes, we have to simplify root 1 plus x square into x cos of cot inverse x, the sine of cot inverse x whole square minus 1 whole square. Now what is this? Can we write this in terms of cos inverse? Yes, this is x by 1. So this is base, this is perpendicular. Cos inverse base is 1. What is the perpendicular? Sorry, base by hypotenuse. Hypotenuse would be 1 plus x squared. So this would be cos of cos inverse 1 by 1 plus x squared. So what is sine of this? So what we can write this sine inverse. Sine inverse, this is sine of cot inverse. So this is x by 1 x. Sine inverse 1 by root 1 plus x square you can also write. So sine inverse we can remove. So 1 by root 1 plus x square. Okay, it's whole square minus 1 whole square. So root 1 plus x square, and this is x plus 1 by root 1 plus x square. Okay, sorry, this is, there should be x here, sorry, because this is base. So base, so this is x square plus 1 by this, it's yes, it's whole square minus 1 whole square. Now if you see root 1 plus x square, now one root would be cancelled actually. So it's whole square minus 1 raised to half. So what is this? Root 1 plus x square. So this is 1 x square raised to half, which is x into root 1 plus x square. Now let's move to last question, which is question number 40. Now in question number 40, we have to find two values. One is x, tan inverse 1 minus cos inverse minus half, the sine inverse half. Now can we find out these values? So this is pi by 4 actually. This is you can easily find out pi minus cos inverse x, which is pi minus pi by 3, and this is pi by 6. What this is? This is minus pi by 4. You can easily find out. What is next? Y equal to cos of half cos inverse 1 by 8. Now how to find out this? See, this is not a standard value. Let this cos inverse, let this be theta. Let. So what is cos theta? 1 by 8. What do you want to find? Cos theta by 2 actually you want to find out. Y equal to cos theta by 2. So can we find cos theta by 2 from here? Of course, yes. So we can write 2 cos square theta by 2 minus 1 equal to 1 by 8. 2 cos square theta by 2 is equal to 9 by 8. So cos theta by 2 is equal to 9 by 4 or 3 by 2 plus minus. Obviously, theta by 2, since theta would be from 0 to pi, so theta by 2 would be from 0 to pi by 2. So cos theta would give you positive value on. So this is actually, this is 3 by 4, sorry. So this is 3 by 4. So x is minus pi by 4 and y is 3 pi by 4. So what is the relation between two? So tan x is equal to, what is tan x? Tan x is going to be minus 1. So this is going to be equal to minus 4 by 3 into y. This is the correct relation, I think. Okay. So hopefully you must have got benefited from this discussion. Okay. So okay, so let's end up our discussion here. Thank you. Bye bye.